Here's our lesson for today. It's called functions and our objectives. Today is Monday, October 5th. No, October 4th. October 4th. There we go. Crazy how fast the year's gone by already for me. So here's our objectives for today. We want to be able to define a function, definition of a function.
Good morning, sir.
Good morning. I'm glad you
وحاجة
made it. Everyone get your paper and copy these down, and we're going to get started. I also want to be able to identify functions from a table, from a list, or from the graph. And we want to be able to use an equation to find outputs given a list of inputs. And then lastly, we talked about domain and range last week, but I want to identify domain and range from a graph. So identify domain and range from a graph. I don't think we've done that yet. So those are four main objectives for today. All right. Good morning to those of you who just joined. We're going to get started now. So get some paper and take notes while we go through this. And I am going to ask to see your notes at the end. If you have any questions while we're going through this lesson, I want you to tell me and I'll just say, hey, Josiah, I need you to stop and explain what the heck you're talking about during this example or back on the last example or whatever the case might be. I would say put it in the chat, but I don't always see that. And sometimes people are sending me private information about maybe they have to leave for some medical thing. And I don't want to put that on the video or let everyone else see it on my screen. So just tell me if you have a question while we're going through this, please. I'm also going to stop and ask to see how you're feeling about what the examples and the definitions we've done so far by showing me your thumb. So thumbs up means you're doing great and you feel like you could teach it to someone else later today. And thumb sideways is I'm doing okay, but I'm still learning and don't feel like I could teach it yet. And then thumbs down is I'm really lost and confused and I need time to go over this more and get more practice. Any questions before we get started, please? Okay, here we go. So start with a little review of last week on Thursday. Last week we started talking about relations in math. So what is a relation in math? It's a relationship between two sets of quantities or variables. It's a relationship between independent variables and then dependent variables. Usually in our equations, those will be the x's and the y's, the inputs and the outputs, the domain and the range. And then I just said this, one set of the quantities or variables is the domain, and the other set is the range. And remember, the domain means all the inputs, all the independent variables. add this into all the independent variables, the inputs, and usually in math, that means the x numbers or x's. I'm just going to say x's. And then the range is all the dependent variables because they depend on the input to figure out what the output is. All the dependent variables. That's another name for that for us is the output. The y numbers, the y's. So start to think of those together. So whenever I say domain, we mean like the list of all the independent variables. And another way to say that is it's all the input numbers, all the x's. And then likewise, the range is all the output numbers, all the dependent variables, all the y numbers. They kind of all go together. Any questions, concerns so far? Okay. And really quick, let's look at a relation in a table. So I'm just going to make up an example quick here. So we saw tables like this last week. And when we have a relation in math listed off with a table, there'll be inputs on the left and then outputs on the right. And then numbers matched up that go together. This is the relationship between the two variables. So maybe we have 0 going to 5. So we don't know what the equation is, and we don't have a graph for this information, but we do know that 0 is the independent variable, and the output that matches up with it is 5. Hey, good morning, everybody. Someone's got their mic on, and if you could just turn that off, I can hear like some kind of tutorial in the background. I appreciate it. I'm glad you're here, but just hit that mic for me. Okay, so there's one entry from what we saw last week in a relation in a table. And then we could have more numbers, right? So 1 might go to 10, and 2 might go to 15, and 3 might go to 20. And I'm going to stop there for this example. So remember, the inputs, usually that's our x's. I'm going to put that up there as well. X numbers, x's. And also we could call it the independent variable. All these different terms, all this different vocabulary kind of goes together. Independent variable. And then the outputs, these are usually in math, the y's, and the dependent variable, because if we had an equation, we would find the outputs depending on what the input was, dependence. And also, let me throw another word in the mix here. Let's see, the domain is the list of the x numbers. So basically everything from that input list is our domain. And then all these numbers that match up with them, the outputs, this is the range. So domain, input, x, and independent variable, those are all the same thing. And dependent variable, y's, outputs, or range, those are all the same thing. We're going to be using this language more and more and more. And I just want you to be used to hearing it one way and knowing what that means, even if we use a different word for it. Okay, and this is all basically a review from last Thursday. Any questions or comments or concerns so far, please? If you have a question on it later, I want you to try the video that I posted for last week. It should be called Graphing Relations. I think that's what it's called. It's the most recent video in the Math 1 playlist. And if you don't have access to that list of my YouTube lessons, then you need to tell me right away. Tell me today. Send me an email so I can get you that list again. Okay. I've probably already emailed it to you before, so you should just search for it in your emails, but tell me if you can't find it so I can help you find it. Okay, so now let's look at the new stuff for today. Today's all about functions. So what is a function? What is a function? A function is a special type of relation. Okay, that doesn't still tell me how to know if I have a function or not. So how do we know if we have a function, or is it just a relation? Is it the special type that we can call a function or not? But here's the formal definition. And then we're going to spend most of the rest of today looking at different types of examples. So for a relation to be a function, every input has its own output. I'm going to add a word in here. Every input has its own unique output. So in order for any relation that we are working with or are given, in order for us to say it's a function, we've got to check this requirement, make sure that every input has its own unique output. Here's an example in a table form. So here's another table. Here's my list of x's and y's below. Remember, this is our inputs. This is the domain, the list of all the inputs. Same thing. And this would be our outputs and our range. Okay. So let's check our list of inputs. So 1 goes to 4, 2 goes to 5, 7 goes to 7, 9 goes to -5, and 10 goes to 8. So did every input that we see, every domain entry, does it go to its own unique output? Yeah, it looks like it does. Yes. Every input or every x value, every domain value goes to its own unique output in the range. So this is a function. This table represents a proper function because it meets this rule. Every input goes to its own unique output. And I want to look at functions and relations in all the different forms. So we could see them in a table like this. We could see them just as a list of inputs and outputs, kind of like this, but looks a little different. And we could see them as a graph. And our job as mathematicians is to be able to say, yes, this is a function, or no, it's not, based on any of those different formats. So remember, what we're looking for is to examine the inputs and then make sure that each one we see goes to its own unique output. Let's look at an example where it's not a function. Next, here we go. A new table is given. Does the table represent a relation or a function? Remember, for it to be a function, every input has to go to its own unique output. So let's look at our inputs. 3 goes to 8, 1 goes to 0, and then 3 goes to 4. Uh-oh. 3 shows up twice, and it goes to different numbers. 3 goes to 8, 3 goes to 4. 3 goes to 8, and 3 goes to 4. That's a problem. That means that we have an input that doesn't have a single unique output. It has two different outputs. This input of 3 does not have a unique outputs. So that means this is not a function. Sad face. Not a function. It is a relation. So it still counts as a matching up of variables, right? It still counts as a matching up of inputs and outputs, domain and range. But so it's a relation for sure, but it's not a function because it doesn't meet that special rule. Sorry, there we go. So that's what we're looking for. Another way to say this is, are there doubled up inputs? So I want you to, that's another way to look for this that might be a little easier to see. So if you're given a list like this table and the last table, look through it and see, are there any doubled up, like repeated? Are there any repeated input numbers? Any repeated domain values? Sure. In this example, 3 shows up here and 3 shows up here, and they go to different outputs, right? 8 and 4. And because that's happening, this is not a function. Any questions so far? Concerns? Comments?
I had a question.
Tira, please.
So with the double out, or I don't know if it's outputs on the right, I mean the left, for 3 and 4.
Yeah. These are inputs. And then the right side is always the output side. Good. Go ahead.
Okay. So every time there's like a double number on the input side, does that mean that it's not a function?
Basically, yes.
Okay.
Yes. And then double check though that those outputs are different, right? Like 8 and 4. Like these are different from each other. We have doubled up inputs, like you said. And like you said, that means it's not a function. Now, the reason I'm saying basically yes and not for sure 100% yes is, what if they had been kind of tricky and done this to us and said, here's the rest of our table below, for example. Let's say we had this. 2 goes to 9, and then 2 goes to 9. So this is a little redundant and silly. Um, but it's a case where we have repeated inputs, right? 2 and 2. But the output is still unique. It's the same value, 9 and 9, right? So it's a little silly, you might think, to show it twice. And I would agree, it is silly. But this is still a function in this case of the 2s, because the 9 is not like a different output, right? It's still a unique, the same one that matches up with 2 already. So this is like a trick question, and it would still be a function. But as it was given to us above with the 3s, they're repeated inputs and they go to different outputs. And that's the problem. That's what makes it not a function, is the different outputs for the repeated inputs.
Okay, thanks.
Sure. Does that help, Tira? Or not really?
Yeah, it helps.
Okay. So yeah, I like what you said. I totally agree. And that's basically what I want you folks to be looking for. Are there repeated inputs that go to different outputs? That's what we're looking for. Let's look at another example in a list format. Okay, actually, right before we get to that, start with me at the top. We haven't talked about this yet, but it's really nothing too crazy, I hope. Functions and relations as a list of points, ordered pairs. So just remember that you've probably seen these before, but just in case you haven't, we can write a single input and a single output as an ordered pair. And what that looks like is a set of parentheses with our input number on the left. We always write that first, and then the output number on the right. Input, output. And I'm going to list off some other terms here that go with those. So just to kind of get used to using them interchangeably. Normally, folks, and soon, we'll be talking about them always really as X's and Y's. So the X number is always the first one and the Y second. What's another word for the list of all of these? It's the domain numbers. And then the range numbers, remember input and output, domain and range. I want you to start to associate these all together. So inputs, X's, and domains, those are all basically the same thing. The domain is technically the list of all the inputs. Range is the list of all the outputs. And what's another term we've had for these? Independent variable. That's the same thing. Independent goes first. Independent, and then dependent is the second one because it depends on the first one. Dependent. So anyways, this is a single ordered pair, and I'm going to really quick next to it just write another small example. So what that'll look like for us is something like this: 5, 4. That means 5 was the input, 4 was the output. 5 was the independent variable, and it led to 4. And that's our little relation there, 5, 4. So that's kind of a review. And now let's look below at another example where we've got a list of ordered pairs. 1, 2, that's its own ordered pair. So remember, that means that means 1 is the input and 2 is its output. And then next to that, we see 4, -1. So 4 is an input, -1 is an output. 3 is an input, 5 is an output. 3 is repeated. Look at that, 3 and 3. And 3 goes to 5 and 3 goes to 7. We have repeated inputs with different outputs. So
that means that's not a function?
It means it's not a function. Thanks, Tira.
Oh.
Not a function. Because of what we just identified, the repeated inputs going to different outputs. So I'm going to write that here. Not a function because of the 3's. Because repeated inputs. So what I wanted you all to see, we can write a relation or a function in this way, right? A list of ordered pairs. And when you see it like this, what we're seeing is each individual entry from the table, but laid out in a line instead of a table. So input, output, input, output, input, output. All the first numbers are the domain, and all the second numbers are the range. Any questions on this, please? Okay, let's try another. Okay, now, I lost somebody. Hope they come back. The vertical line test. So what this has to do with is trying to figure out if a relation is a function, but using the graph, the picture. So sometimes you'll be given the function or the relation graphed out, and we have to decide, is this a function still? So here's the vertical line test, and then we'll look at some examples. So if you can draw a vertical line through the graph, and it intersects the graph more than once, it is not a function. Intersects more than once, not a function. If you draw the vertical line through the graph and it only intersects your graph one time, then it is a function. So what we're doing when we use the vertical line test is, I guess, trying to eliminate or disqualify. We're trying to disqualify a function. If it hits it twice or more, then it's not a function. I have a couple different graphs here that you can sketch out or just take a picture of these, and we'll talk about if they're a function or not. So what we see here is this blue line graphed out, and one side is closed, the other side is open. But imagine drawing different vertical lines straight down and up and down through this blue line. Well, if you just drew one here It intersected it just once, right? Right there. That's okay. And if you did it here, it's still just intersecting it once. And you can see that if you dragged your vertical line from left to right, it's only going to hit this picture one time everywhere, right? It's not like hitting it more than once. So this is a function because it's passing the vertical line test. So I'll say yes, function. Here's another one. This is a graph of a circle. Now, hopefully you see if you drew a vertical line straight down through this circle picture, well, it hits it here and it hits it here. That's twice. It intersected it more than once. So right away, we can say this is not a function. Not a function because it's intersecting the picture, the graph, more than once. Let's try another one. This sideways parabola, this U-shaped graph. So you're probably already seeing it. If you draw a vertical line right here, boom, it hits it twice. So this is also not a function. And then we have another example, this straight line going from left to right, starting right at the y-axis, going to the right. Well, if you draw a vertical line down through it, it's only hitting it once. So this looks like it is a function. And if you try it again over here, it's still hitting it just once. And if you were to imagine dragging the red line from left to right, it never hits it more than once. So this is a function. Yes, function. Happy face. So this vertical line test, what we're asking when we do the vertical line test is really, is there an input that has more than one output? So honestly, folks, we're just doing the same thing we were doing with our table and with our list of ordered pairs, but we're doing it with the picture already graphed out. Here's what I mean. Look at the circle example over here with me. The red line I drew looks like, you know what, I'm going to draw a new one. I'm going to draw one in the positive side. So how about right here? I'm going to draw a dashed line. So the X number right here, this is the X is horizontal and the Y is the vertical. So how far over on the X ruler am I? I'm at 2 little like dashes. So my input here would be 2. So if I had a table for this circle, I'll start a table above. I've got 2 as an input and an output. What is the height of that blue portion? It looks like it's about 1, 2, 3.5. And I'm just estimating, but that's okay for now. 2 is the input, 3.5 is the output. Now, what about the one below? This is still 2 for the input, and the output is negative 3.5. So if we were to have a list of all the points that made up our circle, we would see a whole bunch of repeated inputs. 2 goes to 3.5 and 2 goes to negative 3.5. That's a repeated input with 2 different outputs. And that's the problem. So this is disqualified from being a function. And the vertical line test is just doing that visually, saying, is there an input spot where it has 2 different outputs, above and below? We see it with the circle and we see it with the sideways parabola right here, the example 3. So vertical line test. If you can draw a straight vertical line through your picture and it hits it more than once, it's not a function. Here's 2 more examples of relations, and I want to know, do these represent relations or are they the special type of function? Now, last week we did some relations that were continuous or discrete. So all the different examples I've shown you so far have been continuous when they're straight lines. But these two graphs are discrete. So we didn't talk about that yet today. Let me change my color to purple. So what we see here are some graphed red locations, and those represent inputs and outputs. So for example, this one here, I'm going to circle it in purple on the left side. Its input is its x number. So how far on the x ruler is it? It's at the -5 spot. And how high or low is it? It looks like it's at +5 for its height. So this spot, this ordered pair would be -5, 5 for its input and output. So all these different red dots we see are just ordered pairs of the input and then the output, but we are graphing it to show it visually. So how do we figure out if these represent relations or are they the special type, the function? We're doing the vertical line test. So draw a vertical line through each dot you see, every ordered pair. Okay, this first one here, the -5, 5, vertical line does not hit any other points. So far so good. The next one, vertical line up and vertical line down. I see it won't hit anymore. And if you check the rest on the first graph, it looks like none of these are going to hit another red dot. So I'm doing the vertical line test, just visually scanning it, looking for, does it hit part of the graph more than once? No, this one doesn't. So this is a function. Yes, this is a function. Because vertical line test, it's not hitting any part of the graph more than once. If we check out the second graph, the first point is good. The second point is good, but then look what happens when you get to the third point. It hits this point above and this point below. So this fails the vertical line test, not a function. Why? Because it hits this point and this point. It hits the graph twice or more than once, right? Hits the graph more than once. Intersects the graph more than once. Let's see. There's some more stuff to cover. Any questions so far? We've talked about the definition of a function, and we've looked at identifying, do we have a function from a table and from a list of ordered pairs, and now we've tried to do it from a picture using the vertical line test as well. Let's do thumbs real quick. I'd like to see where people are so far. So if you could turn on your camera real quick and show me with your thumb how you're feeling about everything you've seen so far, functions and figuring out if we have a function. Tira, thank you for telling me. I appreciate that. Thank you. And Savannah and Maria Celeste, I see you both. Thank you. How about everyone else? How are we doing so far? Levi, appreciate the feedback. Thank you. Anaya, I thank you for telling me. All right. All right, I hope everyone else is following along. Here we go. There's a little more to do still today. Now, we haven't talked about this yet. Finding domain and range from a graph. Now, last week we started talking about domain and range, Remember, domain is the list of all input numbers. All inputs. And also, okay, and the range is the list of all outputs. Let me put that down here. So inputs are like the first number in our table. Outputs, the range, is the list of the second numbers in the table. And just remember, when you hear domain in inputs, I want you to think also x's. I want you to think independent variables. When you hear range, that means outputs, that means y's, that means dependent variables. So we want to be able to look at a graphed line or something like the dots that we had on the last example. So I'm going to make a quick drawing example here. So here's my graph, my x coordinate and my y coordinate. So if they give us a graph with just points, I'm going to make a really short first example for this. So let's say they give us this point, and this point. 1, 2, 3, 4. So 3 points are on our graph. 1, 2, 3, 4. So if I wanted to find the domain and list it off, and the range and list that off, then I'm going to look at every point that's graphed and then list off all the x portions of it and then the y portions of it, the left, right location and the up, down location. So this first point here that's over at 1, it's 1 on the x ruler and it's 1 high on the y ruler. So its point could be written as 1, 1. So if I'm listing off the domain for this function we have here, so far I've got a 1 because of the first number. And actually I have a 1 for the range as well. So let's make both lists as we go. Next point. It's 2 on the x ruler, and it's a 3 on the y ruler for its height. So for domain, I can list 2. For its range, I don't list 2 because it's not too high, is it? It's up to the 3. So its range is a 3 so far. 1, 3 for range. And then our third and final point, it's all the way over at 4, see? So for the domain list, I've got 4, and that's it. And then the range is how high is that? Well, it's at the 0 height, so I'm going to put 0 there. So it looks like our domain for this example is 1, 2, and 4. Its range is 1, 3, and 0. When you're talking about domain and range for a graph, think to yourself, what are all the numbers that this graph is covering for its like left rightness? That's our domain. And then all the numbers that it's covering for its height, up and down, that's its range. So let's look at some graphs that are continuous and not discrete like this one, where the line is kind of traveling across the screen. Same question, I want to identify the domain and range of this function. The function is this red line. So now in my picture, it doesn't have arrows, but I'm going to add in some arrows here. That's what was meant by the picture. So in this case, it's traveling all the way, it's at this -6 on the x ruler, and then we see it end kind of right here at 3. But because of the arrows, it's kind of implied that it's going on forever in both directions. So we're not going to list off the entire domain list here because it's all the numbers that exist. It's everything to the left of this line and everything to the right. When I'm looking at the domain, I'm kind of asking how far left does it go? how far left, and how far right. Well, it goes forever to the left and forever to the right in this case for this straight line. So our domain, here's how we say that. Negative infinity, comma, positive infinity. That little sideways 8 symbol, that means infinity. It means it goes on forever. Another way that you might hear this said is all real numbers. The domain is all real numbers. Forever to the left, forever to the right. And spoiler alert, anytime you've got a straight line graphed like our red line is here, it's always going to be all real numbers for the domain. Now we're going to look at the height of this red line, meaning like how far up does it travel? How far down does it travel? So looking on the left side of our picture, and I'm looking at it from like an up-down mindset, if my red line continues out of the screen here, look, it's going down, 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 down forever. So our range, it goes forever downwards, so negative infinity again. And now we want to look at how high the thing travels. And likewise, if our red line were to continue, right, and if our picture was bigger, it goes up higher and higher and higher, right? So it's going for infinity on the top as well. And again, you could say the range here is all real numbers. All real numbers. So when your graph is basically traveling forever off the screen and to the right off the screen, it's safe to say the domain and range is all real numbers. But it won't always be that simple. What if they kind of cap off our graph at some point? And let's look at an example or two of what that looks like. So here's another one. Just take a picture of this or do a quick sketch on your paper. I don't want you to spend too much time making this a perfect graph. So this is another relation or function. I guess first, is this a function? Let's make sure using our vertical line test. Imagine drawing a straight line down through the graph. At no point does it hit it more than once, so this is a function. Let's talk about the domain. Now this time, it's capped off right here. Capped off. Stopped. Bounded. It's bounded right there. So that means it doesn't continue forever to the left. So if I'm asking about how far left and right this graph goes, think about it this way. I'm going to show it down below. It's capped off here at -2, and it does continue going rightwards all the way off the screen, right? It goes all the way off the graph. And if our picture was zoomed out, then it looks like it would continue with that arrow onward and onward towards the right. So our domain here goes from -2 to infinity. So if I just said it out loud with like language, I would say the domain goes from -2 to infinity. To write that in math symbols, show the number on the left that it's bounded by, so -2, and then if it's infinity, we put that on the right. If it goes on forever, that's our right. And I did use two different types of brackets. If it's closed off somewhere, like it was at -2, we usually use the hard bracket, the straight up and down one. And then if it's a forever thing, if it's infinite, use the softer curved parenthesis. And there's one more way that we could say the domain for this. It's all the x numbers that are equal to -2 and bigger than -2. Right? Like -2 is in the domain of if we were to list this off. because it's over that far to the -2 leftwards, right? And -1, it's right there, and it's at x is 0, and it's at x is 1, and x is 2, x is 3. The point is, it's every x number equal to -2 and bigger. So we could say the domain is x greater than or equal to -2. So we're listing it off as an inequality. X is greater than or equal to -2. And so far, we've just talked about the domain. How far left and right does our picture go? Now let's look at the height. I'm going to change my color to like yellow here. Actually, yellow is kind of hard to see. Let's do red. Okay, so now the range. How high and low does this thing go? So look at the lowest most point of the graphed line. And in this example, it looks like it's kind of capped off right here. See? It doesn't go past that horizontal line. So the lowest that this picture goes looks like it's at here, -4. And how high does it go? Well, traveling upwards on our line, it does go up forever. This arrow right here is symbolizing it's going to continue in the same way outside the picture. So it's going upwards forever. So we would say that this goes from -4 to infinity. This time, because we're talking about height, when I say the range goes from -4 to infinity, that means the lowest point on the picture is -4. The highest point is, who knows? It just goes on forever. To show it with symbols, we would say 4, -4, infinity. And then to show it with a little inequality, we would say y greater than or equal to -4. It changes to y if we're talking about range. Remember, x goes with domain, y goes with range. Y goes with heights, x goes with left-rightness. Okay, it's 11:50. I want to show you a little bit more, and I'm sorry we're probably not going to have time to do our mastery test together. But just so you all know, the homework for today, let me go back. The homework for today is going to be to do the next mastery test called functions. You'll do 5 problems that are just like these ones I'm showing you today. Okay, let's do some examples of what we just started. So finding, sorry, I'm going to step over and we're going to try some last new topic for today that goes along with what we've been doing. So we're going to find the range of a function given a list of domains. So kind of a word problem, but not really, because there's no story here. It's just written out for us. Find the range of the function. Y equals 2x plus 1 given the domain 0, 5, 9. Domain means the list of all inputs. List of all inputs. So that means 0, 5, and 9 stand for x numbers. These are all x's. And we're supposed to find the range that goes with this domain 0, 5, and 9. So how do we find the range that goes with this domain? You take the equation, y equals 2x plus 1. We're going to plug in the x numbers, the input numbers, one at a time. So I'm going to start by plugging in a 0 for x. So this is now like what we were doing in the first unit when we were simplifying and evaluating linear functions. So I plug in my 0 for x, and I multiply and add 1, and then we get a y number, and that's our range number. So 0 times 2 is 0. 0 plus 1 is 1. So y equals 1. So when I plug in 0, my output is 1. So let me make my answer at the top here. Range equals, I'm going to make a list to go along with how it was given to us. It was given to us as a list, and we found 1. So we start over now. Y equals 2x plus 1, and we plug in 5 for x. So it's the same equation each time because this function is the whole equation. Y equals 2x plus 1. 2 times 5 is 10, plus 1 is 11. So when our input is 5, our range number, our output is 11. And then we do it again, plugging in 9. 2 times 9 is 18, plus 1 is 19. So the range that goes with that given domain is 1, 11, 19. If this was in table form, it would look like this. Our x's, our inputs would have been 0, 5, and 9. And then our outputs, our range numbers, we just found 1, 11, 19. Just so that you see the connection between the different formats, the table, the list, or we could graph these if we needed to. All right. Any questions on this topic, please? I want to hear from you. Okay, that is all I have to show you today. I know it was kind of a big lesson, but it was all related with finding domain and range and identifying, do I have a function or not, based on our rule. So I want you to now start the mastery test. And I know we've only got 5 minutes, but start your mastery test in Edmentum. That's called functions. And all the 5 problems you get will come from the same stuff I showed you this morning. I'll be posting the video after lunchtime, and you can go back and look at it again if you need to.